Hi everyone, and welcome to Basic Chemistry 1, and I wish you a very happy new year 2019. The topic of this video is molecular mass. In our previous video we have discussed what a molecule is, and we have defined it as the smallest particle of a substance, that is an element or a compound that can exist free in nature. Today we are going to discuss the molecular mass. So as the name molecular mass suggests that it is the mass of one molecule of a substance. So we can define it as the molecular mass of a substance or a molecule is the sum of the relative atomic masses of all the atoms present in one molecule of that substance. That is, the relative atomic masses of all the atoms that make one molecule of a substance. So we can also say that the molecular mass of a substance is calculated by adding up the relative atomic masses of all the atoms that are present in one molecule of that substance. Let us take an example to understand the concept of molecular mass. For this purpose, we are taking the molecular mass of C2H6, that is ethane. So as can be seen from this formula, that one molecule of ethane is made up of 2 carbon atoms and 6 hydrogen atoms. So to get the molecular mass of ethane, we will have to add up the mass of the relative atomic masses of 2 carbon atoms and 6 hydrogen atoms. In this way we will get the molecular mass of ethane C2H6. So here I have solved this problem. I have calculated the molecular mass of ethane. So we know that the atomic mass or the relative atomic mass of carbon is 12 AMU, and that of the hydrogen atom is 1 AMU, and the formula of the ethane is C2H6. So I have split this formula in a way to calculate the relative atomic mass of ethane. 2 times the relative atomic mass of carbon plus 6 times the relative atomic mass of hydrogen. So 2 multiplied by 12, this is 2 times the relative atomic mass of carbon plus 6 multiplied by the relative atomic mass of hydrogen, which is 1. So the total comes out to be 30. So 30 is the relative molecular mass, or we can say the molecular mass of ethane. Similarly, in this example we have discussed that the molecular mass of ethane is the sum of the relative atomic masses of all the atoms that make one molecule of the ethane. Now, can you suggest what the molecular mass of H2o, that is water, and carbon dioxide? Let's do some work over it. As you know that the formula of water is H2O. It is a combination of 2 hydrogen atoms and 1 oxygen atom. So to calculate the molecular mass of water, we will have to take 2 times the relative atomic mass of hydrogen plus 1 time we will have to take the relative atomic mass of oxygen, and we know that the relative atomic mass of hydrogen is 1 AMU and that of oxygen is 16 AMU. So you can see that in this way the relative molecular mass or the molecular mass of water comes out to be 18 AMU. Similarly, for carbon dioxide, that is CO2, the formula CO2 suggests that one molecule of carbon dioxide is made up of 1 carbon atom plus 2 oxygen atoms. So here I can calculate the molecular mass of carbon dioxide is 1 multiplied by the relative atomic mass of carbon, which is 12, plus 2 multiplied by the relative atomic mass of oxygen, which is 16. So 1 multiplied by 12 we get 12, plus 2 multiplied by 16 we get 32. 2 times 16 is equal to 32, and the total of these two terms comes out to be 44. So we can see that the relative molecular mass, or simply the molecular mass of carbon dioxide, is 44 AMU. So in this way we can find out the molecular mass of each and every molecule, whether it is a molecule of an element like H2, the molecule of hydrogen, O2, the molecule of oxygen, N2, the molecule of nitrogen, and so on. So in this way we can find out, we can calculate the molecular mass or relative molecular mass of the molecule of a substance or a compound. Hope you have enjoyed this video. Thank you for